Combing your dry hair is always a problem, isn't it? But have you noticed it? After you have combed your hair for some time, the hair gets attracted to the comb on its own. But you apply oil to your hair and comb it again. Now there's no attraction. What's going on? What causes the attraction between dry hair and comb that's missing in the oiled hair? We'll find out in this episode. Hello and welcome to our episode on electric charge. How often have you walked across a carpet, opened a door and felt a shock? How often have you waved your hand across a computer monitor and felt that the air was crackling? There are times that a simple comb would pass off as a magician's wand as you find it attracting strands of hair. All this is due to static electricity. In this episode, we'll discuss the types of charges and their behavior, mechanism of charging conductors and insulators, which is by contact and by induction, and of course, we'll make you bridge the gap to that perfect score in your exam in the exam decoded section. Before we discuss the types of charges and their behavior, let me tell you from where these charges originated. Well, all atoms are made up of electrons, protons, and neutrons. Electrons are negatively charged particles, protons are positively charged particles, and neutrons are neutral by nature. Typically, a material does not have a net charge because there are equal number of electrons and protons in each atom. However, a material can develop a net positive charge and become positively charged if we remove electrons from some of the atoms. Similarly, a material to which electrons are transferred will have excess electrons and hence will become negatively charged. The SI unit of charge is Coulomb. It is denoted by the symbol C. The magnitude of charge on one electron is exactly the same as the magnitude of charge on one proton, which is E is equal to 1.6 times 10 power minus 19 Coulomb. If one material transfers its electron to another material, is the amount of net negative charge on the material that gains electrons the same as the amount of positive charge on the material that loses electrons? Yes, it is. Now let's understand this with a graphic. Before the electrons are transferred, the material is neutral. If n electrons are transferred from one material, it will have n protons without partners to neutralize them. Thus, the magnitude of net positive charge on one material will be n times E, and the magnitude of the net negative charge on the other material will also be n times E, where E is the magnitude of charge of one electron or one proton. Physics is all about numericals. This one was posted on our website, topperlearning.com, by one of you. If you solve this one, you will fare well in the ones to come. If a material has a net positive charge, Q is equal to 10 power minus 6 Coulomb, how many electrons have left the material? Well, we can figure this out easily. Let n be the number of electrons that left the material. This is equal to the number of excess protons present in the material. Since excess charge Q is equal to n times E, n is equal to Q divided by E. On substituting the given value of Q and recalling that E is equal to 1.6 times 10 power minus 19 Coulomb, we get the approximate number of electrons, n is equal to 10 to the power 13. Based upon electrical properties, materials can be divided into two categories: electrical conductors and insulators. Conductors are materials that have a large number of free moving electrons that are not bound to a particular atom. For example, metals such as copper, iron, zinc, etc. Insulators are material that do not have free electrons. In these materials, each electron is bound to a particular nucleus. For example, plastic, PVC, wood, etc. But that is theoretical. Physics is real. So let's look at some efficient methods of charging these materials. Let's start with insulators. Insulators can be charged by rubbing one type of insulator with another type of insulator. Let's take two PVC rods, rub them independently to a silk cloth, bring them close, and see what happens. They repel each other. Now what if we take two plastic rods, rub them independently to a woolen cloth, and bring them close? Let's see. They also repel each other. Now what if a PVC rod rubbed with silk is brought near a plastic rod that is rubbed with wool? What do you think should happen? Let's see. They attract each other this time. See? Do you find that strange? I don't think so. Let me tell you why. Rubbing results in transfer of charges, and hence charge imbalance occurs in things that are rubbed. Like or similar charges repel each other. Both PVC rods on rubbing with silk acquired a similar charge. So the PVC rods repelled when they were brought close to each other. Unlike charges attract. Two differently charged plastic and PVC rods attracted each other. Remember that charging a rod by rubbing does not create charge. It simply transfers charges. For example, the negative charge from the silk transfers to the plastic rods. This leaves the silk with an equal amount of positive charge because the silk and the rod were originally neutral. I'm sure all this talk has left you charged up to answer a question now. Can a charged insulator be discharged by passing it over a flame? Think about the answer. I shall answer it after the break. For more such teasers, don't forget to visit our website, topperlearning.com. Stay tuned.